everybody. Yes, you are correct. Today we get to have more fun with piecewise functions. I'm glad you got that. All right. Today we have two tables on the left here on your screen, and it says that the two tables represent two pieces of a piecewise function. Okay. You know how a piecewise function has multiple parts. These are two parts of it. One piece of the piecewise function is represented by this function right, or this table right here. The other part is represented right here. Great. Write the equation for the piecewise function. You guys are going to think this is so totally easy because there are just two parts. First, we have to write the domain of the data in the table. And so we have to ask ourselves, what is the domain of the data in each table? The domain for the first table is just the list, or the range of the x values. X can be between 0 and 4, so the domain is all real x such that x is greater than or equal to 0, less than or equal to 4. I'm assuming that the data goes on continuously and it's not just these certain points. That's why I'm saying all real x. Okay? The next part, that was for the first part. The next part is what linear equation is represented by the data in each table. Well, that's pretty simple too. We've done this over and over and over again. Okay? So what we have to do here is we just have to say, well, what is my slope and what is my y-intercept? Because my equation y equals mx plus b just requires that. It is real easy for me to find my y-intercept because, or on this graph anyway, because look, the y-intercept is where x is 0. I already am told that my y-intercept is 0. So now I have y equals mx plus 0, which, by the way, is just mx. Okay? Now all I have to do is find my slope, and I'm done. Well, you guys all know how to do slope by now. We are going to take the slope formula, m equals y2 minus y1 over x2 minus x1. Okay? And I am going to say, I'm going to use the points about 0, 0. Those 2 points there, that point there, and the point 1, negative 2. Right? So, my slope is going to be y2, negative 2 minus 0 over 1 minus 0, which is just negative 2 over 1, which is just negative 2. So my equation, y equals negative 2x plus 0, which I don't have to write. That is my equation, and this is my domain here. Okay. Now what I have to do, first, what I'm going to do, I'm going to group all of this, and I'm going to shrink it down so I can do the same thing. You can write wherever else you have room on your paper. I'm just going to grab this, I'm going to group it all, so that's good enough. For the next one, this second table here is what I'm working with now. Okay? I am now going to do the exact same thing. Say the domain and what the equation is. Domain is going to be just the x values again. All real x between 5 and 9. All real x such that x is greater than or equal to 5, less than or equal to 9. Okay, pretty simple. And now, once again, all I have to do is find my equation. I'm going to start with y equals mx plus b. And I'm not going to get lucky on what my slope or my what my y-intercept is anyway, because it's not 0. So I actually do have to do some work. First thing now I'm going to do is my slope. I have because I could use the same slope formula. y2 minus y1 over x2 minus x1. And I'm going to pick, say, these 2 points here. No, you know what? I am not going to pick that point. I'm going to pick my first 2 that don't have negatives, because that makes it a little easier. 7, 1, and 8, 4. So when I go to fill this in. Y2 is going to be 4 minus 1 over 8 minus 7, which is going to be 3 over 1, which is just going to be 3. Just notice those 3. Now I have to find my y-intercept, and here's where we're going to use our little trick about using the y equals mx plus b form, and briefly plugging in x and y. First I'm going to replace m with my slope. I know it's 3, and it's always going to be 3. Okay? Now what I'm going to do, in order to find b, I'm going to temporarily plug in one of my points for x and y. I'm going to use this one right here. 1 always makes my life easy. So I'm going to use 7, comma 1. 7 is my x, 1 is my y. Okay? So I go back to my pen. I'm going to plug in 1 for y, 7 for x, and figure out what b is. Okay, 1 is equal to 21 plus b. Take away 21 from both sides. 1 minus 21 is negative 20. That's going to be my b. And I found b. I already know my slope. So my equation, y equals y equals mx plus b, is going to be y equals 3x minus 22. Great. So am I done? Let's see. Let's move on. No, I'm not done. I thought you were done, didn't you? Okay. What I wanted to do was I wanted to find the piecewise function. Write the equation for this piecewise function. It says it right here. Okay? We haven't quite done that yet. We've done all the parts we need, but now we need to put it all together. To do this, I'm going to do this. I'm going to take part 1, and I'm going to say, great, I know my domain, I know my equation, and so I'm going to just put it together. F of x, or y, f of x is equal to negative 2x for my domain, for x is in, let me just get a little bit more room. Probably getting crowded here. So negative 2x for my domain, which I have already established, is x is between 0 and 4. For 0 less than or equal to x, less than or equal to 4. Okay? And now I'm going to do the second part. The second equation that I just found, which is right here, y equals 3x minus 2. So I'm using the function notation, so f of x is equal to 3x minus 2, or I'm sorry, that's minus 20. And that's going to be for my second domain, the domain of this second table, which is all real x between 5 and 9. So for 5 less than or equal to x less than or equal to 9, and I'm done. That is the way that you can go from a table to your piecewise function. So let's review that. There are really 4 parts to it, or 2 parts, and we repeat them. The first thing we have to do is we have to find the domain of this first table here. Okay? Then once we find the domain, we have to just find our equation, which we've done lots and lots of times. We put all of that, equation and domain, in the first part of my piecewise function. The second part, I have to find the domain of the second table. That's right here. Remember, it's really just all of the x values. That's my domain. And I find the equation of this table, which I've done lots and lots of times before, and I put the equation there, and domain there. I'm done. I'm going to do one more. A second example. What's the domain of the data in each table? What linear equation is represented by the data in each table? Okay, so my domain for this one, I'm going to skip the all real x part because I run out of room quickly here, but you can write smaller than I can. So you can go ahead and write all real x. But my domain here is just that. So I'd say x is in between negative 3 and 1. For that. Okay? For the second one, x is in between 10 and 14. So 10 are equal to x, less than or equal to 14. I found my domain. And really, if I wanted to, I'm going to skip down to where I'm going to start writing my piecewise function. F of x is equal to, I don't know my equations yet, but I do know my domains, so I'm going to go ahead and write them. For x is in between, I think there's negative 3 and 1. Yeah, negative 3 and 1. And the second part is going to be for x is in between 10 and 14. Check that. It is. Okay? So I already have the first half of my piecewise function written. Now all I have to do is find the equations. Okay? And so to find the equation here, I'm going to do the exact same thing I did before. And I'm going to get lucky again. Notice my y-intercept is when x is equal to 0. I know what my y value is when x is equal to 0, so that's my y-intercept. Okay? So I have y equals mx plus b, but this, I know my y-intercept is negative 8, so y equals mx minus 8. Now all I have to do is find my slope. I'm going to find my slope by taking 2 points. How about this point here, and this point here, 0, negative 8, and 1, negative 6. So, do y2 minus y1, negative 6 minus 8, over x2 minus x1, 1 minus 0. So negative 6, oh, I made a mistake. It's negative 6 minus negative 8. Remember, you are subtracting. They both happen to be negative. So it's negative 6 minus negative 8, which means negative 6 plus 8, which is going to be 2. 1 minus 0 is just 1, so my slope is 2. I have my equation now. I'm done with that one because I got lucky. I already knew my y-intercept. This means this is y equals 2x plus 8. I can go ahead and put that down in here. F of x is equal to 2x minus 8. Now all I'm looking for is my last equation there. I already know what its domain is, and I'm done with my piecewise function. So let's go ahead and try to find that. We will not get lucky again knowing the y-intercept, so we'll just have to do it the long way. It's not really that long. First thing I'm going to do, find my slope. I'm going to pick 2 points. I cannot avoid negatives, so I will just pick about this point here and this point here. y2 minus y1 is negative 5 minus negative 6, and x2 minus x1 is 11 plus 10. So my slope is going to be negative 5 plus 6, which is just 1, over 11 minus 10, which is just 1. So my slope is 1. It's easy. Y equals mx plus b, so y equals 1x plus b. Now all I need to do, grab another point, or any point on there, I'll pick 14, negative 2 just for fun, and plug it in for x and y temporarily to find b. Y is negative 2 equals 1 times x is 14 plus b. So I get 2 equals 14 plus b. Let's figure out what b is. Minus 14 minus 14. Negative 2 minus 14 is negative 16, and that equals b. Now if I just put this all together, I am done. So I have y, change colors, so y equals m, which is 1x minus 16. And remember, I do not really need to write this 1 because x means the same thing, so I'm going to just cross that out. And there's my equation for the second part. I put it in my box here. F of x equals x minus 16. I already have my domain. I have created this piecewise function. Next, you are going to do the same thing with this question right here. And we're going to sum up with a final question. I want to sketch the graph of the function to the right and state whether or not it has any gaps. Okay? All I need to do is graph each of these, this part here, and then this part here separately, and I need to it for the proper domain. So the first one is for x is greater, or sorry, x is less than 2. What I'm going to do, I'm going to put an imaginary line. I'll use a dotted line, thin dotted line, and I'll do it in a bright color, bright yellow. And I'm going to put that where x is 2. That is not easy at all. So let's make this bigger. Put it a little too big so that we can just like that. Okay, there we go. That is the line x is equal to 2. Remember, if my domain is x is less than 2, that means that this graph is only going to be on one side or the other of this line, this yellow line that I have drawn. So now all we have to do is figure out what does the graph of absolute value of x look like. The easiest way to see that is maybe with a table. Okay, so I'm going to use x and y. I'm going to start with -2, -1, 0, 1, and 2 will be the last value I can possibly put on. Okay? What is the absolute value of f of x equals the absolute value of x? So when I put in a -2 right here, what do I get out? I just get out +2. When I put in a -1, I get out a +1. When I put in 0, I get out 0. Put in 1, get out 1. Put in 2, get out 2. Really quite an easy function. So let's go ahead and graph this. -2, 2 would be right there. -1, 1 right there. 0, 0 right there. 1, 1 right there. And I will have 2, 2. But remember, it can't actually equal. It can just be less than. I'm going to put an open circle on 2. And I have this graph, which I'm going to complete now. And I'm going to say that that is my graph. I'm going to label it f of x equals absolute value of x. Okay? And remember, this is my f of x axis. This is my x-axis. And now all I have to do is graph the second part. So I'm going to erase some of these marks I've made here. I need to graph the function f of x negative x plus 4 if x is greater than or equal to 2. Well, I know how to graph this function. I can say that my slope is -1 and my y-intercept is 4. And I will just, okay, I'm going to erase this because it's actually in my way here to show you guys what I'm doing here. So I'm going to erase that, but you can leave it on yours, I'm guessing. Okay, I know my y-intercept is 4 right here, and my slope is -1, which means I go down 1, over 1, down 1, over 1, down 1, over 1. But remember, I can only use this line for greater than or equal to 2. So it turns out that the equal to 2 part is at 2, right where the hole was from the other part. So I'm just going to fill that in with my red line. Continue that way. And that is my function right there. This is f of x equals -x plus 4. Okay, so now we're just going to state, are there any gaps in this function or not? What that means is, do I have a graph that looks kind of like this, where one part of it goes like this, and another part of it goes like this? Well, the gap would come in right here where these are not connected. Turns out that my graph right here is connected because the two endpoints meet. So what I would say, does it have any gaps or not? No, it doesn't. This graph is complete. You're going to try one on your own, and we're going to be done. Thanks for watching.